Imagine that tomorrow 30% of everything you eat disappears. Not gradually, not over decades, instantly. Your morning coffee, apples, almonds, blueberries, melons, chocolate, simply gone. No warning. No déplacement. No way back. This is not a science fiction dystopia. This is exactly what would happen if bees disappeared from Earth. And the frightening part is that they're already disappearing. But before we talk about collapse, you need to meet the main character of this story. Because a bee is not just an insect that might sting you in a park. The bee is one of the most sophisticated, ancient, and important creatures that has ever existed on this planet. A living being that has spent more than 100 million years perfecting itself. A creature that builds cities without architects, makes decisions without leaders, produces a substance that does not spoil for 10,000 years, and unknowingly carries something close to the fate of human civilization on its tiny yellow legs. This is its story. The story begins long before the dinosaurs disappeared. Around 100 million years ago, during the Cretaceous period, Earth was a completely different world. At that time, there was a wasp, a carnivorous, predatory wasp that hunted other insects to feed its larvae. At some point in this distant past, something extraordinary happened. That wasp began collecting pollen instead of prey. No one knows exactly why. Perhaps it was an accident. Perhaps a small mutation slightly changed its feeding preferences. But that tiny evolutionary shift changed everything. That wasp became the first bee, and flowers on Earth would never be the same again. The relationship between bees and flowering plants is one of the longest and most productive partnerships in the history of life on Earth. A perfect symbiosis. A biological contract renewed continuously for 100 million years. Plants evolved to produce nectar, a sugary, energy-rich liquid, specifically as a reward for pollinators. Flowers developed vibrant colors, elaborate shapes, and powerful aromas not for humans, but for bees. And bees, in return, evolved bodies designed to harvest that nectar with almost supernatural efficiency. Think of a bee's body as a perfectly optimized harvesting machine. Its tongue, called a proboscis, is long, hairy, and spoon-shaped at the tip, designed to extract nectar from the deepest flowers. Its hind legs contain special structures called corbiculae, tiny baskets of stiff hairs where pollen is packed with a skill that would impress any craftsman. Its abdomen contains glands that secrete wax, the building material of the entire hive. Its compound eyes can see ultraviolet light, a visual dimension completely invisible to us, where flowers display glowing landing strip patterns that guide bees directly to nectar. A bee does not simply visit a flower. It reads it, interprets it, and knows exactly where the reward is before it even lands, guided by signals humans cannot see. But individual anatomy is only half of the story. Because the bee, as we know it, does not live alone. And this is where the story becomes truly fascinating. The hive is one of the most complex social structures in the animal kingdom. A typical colony contains between 20,000 and 80,000 individuals. But they're not just a crowd of insects living together. In a very real sense, they're a single organism. Biologists call it a superorganism, and the metaphor is perfect. Just as your body is made of billions of cells cooperating to keep you alive, a hive is a living system made of tens of thousands of individuals functioning as one. At the center of everything is the queen. And here we need to destroy a major myth. The queen does not rule. She gives no orders. She does not control the hive with superior intelligence. The queen has one biological function, and she performs it with absolute dedication: laying eggs. During peak productivity, she can lay up to 2,000 eggs per day, one every 40 seconds for several years. She is essentially a reproductive engine. Her power does not come from authority, but from pheromones. Chemical signals that maintain social order, suppress reproduction in worker bees, and keep the colony unified. If the queen dies, those pheromones disappear, and something remarkable happens. The workers reorganize. Within hours, they select a young larva, genetically identical to any worker, and begin feeding it exclusively royal jelly, a substance produced by special glands in nurse bees. That privileged diet activates dormant genes. The larva develops differently. Larger body, functional ovaries, lifespan measured in years instead of weeks. A new queen is born not through destiny, but through nutrition. Pure biological democracy. Worker bees, all female, are the backbone of the hive, but they do not perform the same job throughout their lives. Over their short lifespan of just 4 to 6 weeks in summer, a worker performs completely different roles depending on age. In the first days, she cleans and cares for larvae. Then she produces royal jelly and feeds the young. Later, she builds honeycomb using wax secreted from her own body. After that, she guards the entrance, ready to defend the colony with her life. And finally, in the last stage of her existence, she becomes a forager, collecting nectar, pollen, and water. Each bee is essentially an entire company condensed into a 2-centimeter body. The drones, the only males in the colony, live dramatically different lives. They do not collect, build, or defend. Their single purpose is to mate with a queen from another colony. If they succeed, they die immediately after mating. If they fail, they live a relatively idle life until autumn, when workers expel them from the hive to avoid wasting resources during winter. Nature has no room for inefficiency. And now we reach the most cinematic moment of this story: communication. Bees do not speak. They have no vocal cords, no written messages, no articulated sounds. Yet they communicate with a precision that would impress any telecommunications engineer. They use one of the most sophisticated symbolic communication systems in the animal kingdom, something scientists took decades to understand, and when they finally did, it stunned the scientific world. The bee dance. When a scout finds a rich nectar source, she returns to the hive and begins moving in a very specific way across the comb. If the source is close, less than 100 meters, she performs a rapid circular dance that simply signals, there is food nearby. Go search. But if the source is far away, she performs something far more complex, the waggle dance. She runs in a straight line while vibrating her abdomen vigorously, then loops back, repeats the line, and traces a figure-8 pattern again and again. Within that simple choreography lies a shocking amount of information. The angle of the straight run indicates direction. Straight upward means the food lies in the direction of the sun. 30 degrees left of vertical means 30 degrees left of the sun. The duration of the waggle run indicates distance. The longer the run, the farther away the food. The intensity of the vibration communicates quality. The more enthusiastic the dance, the richer the reward. All of this happens in total darkness inside the hive. The receiving bees do not see the dance. They feel it through vibrations and specialized antennae. It is a tactile language encoded in movement. And this is only the beginning of how extraordinary bees truly are. What happens next is where the hive begins to feel less like a colony and more like a living mind. Because once the waggle dance spreads information through the hive, something remarkable unfolds. Decision-making without a leader. Hundreds of foragers may watch a dance, memorize the direction, and leave the hive like tiny guided missiles heading toward invisible coordinates across fields and forests. Some return successful. Some fail. Some discover even better locations. And when they return, they dance too. Soon the hive floor becomes a vibrating map of competing ideas. Different bees advertise different flower patches with different dance intensities. The better the nectar source, the more energetic the dance. The more energetic the dance, the more followers it recruits. Over time, weaker dances fade and stronger dances dominate. No. Central authority compares options. Nobody has a map. This collective intelligence becomes even more dramatic when a hive must move. When a colony grows too large, it splits. Roughly half the bees leave with the old queen in a swirling cloud called a swarm. For a short time, tens of thousands of bees hang together in a living cluster on a tree branch, exposed and vulnerable. Inside this cluster, scouts fly out in all directions searching for a new home. They examine hollow trees, rock cavities, abandoned structures, any space that might protect the colony. When they return, they perform waggle dances to advertise their discoveries. Some locations are poor. Some are good. Occasionally, one is perfect. Dozens of scouts may support different options at first. The debate can last for days, but gradually consensus forms. The best site attracts more supporters, who dance more intensely, who recruit more followers, until the entire swarm agrees. Then, in a breathtaking moment of unity, thousands of bees take off simultaneously and fly directly to their new home. No leader commands the departure. The signal emerges naturally from consensus. A city relocates in midair, guided by shared intelligence. Inside the new home, construction begins immediately. Bees do not use blueprints. They do not have architects or engineers. Yet the structure they build is one of the most efficient designs ever discovered, the honeycomb. A honeycomb is made of hexagonal cells arranged in repeating patterns. The hexagon is not chosen randomly. Mathematicians have proven that hexagons store the most volume using the least material. With minimal wax, bees create maximum storage space and structural strength. They discovered this optimization millions of years before humans understood geometry. To build this structure, worker bees secrete tiny flakes of wax from glands on their abdomen. They chew the wax until it becomes soft and moldable, then shape it into perfect hexagons. Thousands of bees work simultaneously, each contributing small pieces. No single bee understands the full structure, yet the finished comb emerges flawless. It is another example of how simple individuals create extraordinary complexity through cooperation. But why build such vast storage? The answer lies in the substance that has fascinated humans for thousands of years: honey. Honey begins as nectar, a watery liquid containing sugars. Forager bees collect nectar and store it in a special organ called the honey stomach, separate from their digestive stomach. During the flight back to the hive, enzymes begin transforming the nectar chemically. Once inside the hive, the nectar is passed from bee to bee, repeatedly regurgitated and consumed, each transfer adding more enzymes. This process breaks complex sugars into simpler ones and reduces water content. Then bees deposit the liquid into honeycomb cells and fan their wings rapidly to evaporate remaining moisture. What begins as thin nectar becomes thick, golden honey. The final product contains very little water and has high acidity and natural antimicrobial compounds. This combination creates a substance so stable that bacteria cannot grow inside it. Archaeologists have found jars of honey in ancient tombs that are still edible after thousands of years. Honey is not just food. It is long-term survival condensed in a liquid form. The hive produces honey for one reason: winter. During cold months, flowers disappear and foraging becomes impossible. The colony survives entirely on stored honey. A healthy hive must produce far more honey than it consumes during summer to build a winter reserve. This is why bees work tirelessly while flowers bloom. A single worker bee may visit thousands of flowers in one day. Over her lifetime, she produces less than a teaspoon of honey. To produce a single kilogram, bees collectively visit millions of flowers. Every drop represents an enormous investment of energy and time. And yet honey is only a side effect of the bee's most important role. While moving from flower to flower collecting nectar, pollen grains stick to their bodies. When they land on another flower, some of that pollen rubs off onto the plant's reproductive structures. This transfer allows plants to produce seeds and fruit. This process is pollination, and it is the invisible service that supports ecosystems and agriculture worldwide. Many plants can reproduce without bees, but they produce far more fruit and higher quality seeds when pollinated by them. Some crops depend almost entirely on bee pollination. Almonds, blueberries, cherries, cucumbers, pumpkins, and many others rely heavily on bees. Without them, yields drop dramatically or disappear altogether. The diversity of foods humans enjoy exists partly because bees move pollen from flower to flower thousands of times every day. Beyond agriculture, wild ecosystems depend on bees even more. Flowering plants form the foundation of food chains. When plants reproduce successfully, they feed herbivores, which feed predators. Remove pollinators, and entire ecosystems begin to unravel. Forests, grasslands, and meadows would slowly change as plant species disappear. Animals that rely on those plants would decline. The ripple effects would spread through the natural world in ways that are difficult to fully predict. Despite their small size, bees connect countless living systems together. They link sunlight, soil, water, plants, animals, and humans into one continuous chain. Their daily work is quiet and mostly invisible, yet it supports much of life on land. And for millions of years, this partnership between bees and flowers has remained stable. But in recent decades, something has begun to change. And this is where the story starts to become worrying. For most of human history, bees worked quietly in the background of civilization. Farmers depended on them without fully understanding them. Wild ecosystems relied on them without any awareness at all. The partnership between bees and flowering plants had survived ice ages, asteroid impacts, and mass extinctions. For more than 100 million years, the system remained stable. Then, within the last century, something unprecedented began to happen. Bee populations started to decline. At first, the changes were subtle. Beekeepers noticed hives that seemed weaker than usual. Colonies that once survived winter easily began to struggle. Honey production fluctuated. Losses increased. But in the early 2000s, the problem suddenly became impossible to ignore. Entire colonies began disappearing almost overnight. Worker bees would leave the hive to forage and simply never return. The queen remained. The honey remained. The young remained. But the workforce, the thousands of bees that kept the colony alive, vanished. This phenomenon became known as colony collapse disorder. Imagine opening the door of a city and finding it full of food, homes, and children, but no adults anywhere. That was the mystery beekeepers faced. Scientists around the world began investigating, and what they discovered was unsettling. There was no single cause. Instead, bees were facing a perfect storm of threats that had never existed together before in their evolutionary history. One of the most significant threats is habitat loss. Over the past century, humans have transformed vast landscapes into cities, roads, and large-scale agriculture. Fields that once contained diverse wildflowers have been replaced with monocultures, enormous areas growing only one crop. For a short time, during blooming season, these fields provide abundant nectar. But once the bloom ends, they become biological deserts. Bees need a continuous variety of flowers throughout the entire season to survive. Without it, they face long periods of starvation. Urban expansion adds another challenge. Roads and buildings fragment natural habitats into isolated patches. Bee populations become separated, making it harder to find food and maintain genetic diversity. A landscape that once supported thousands of pollinator species becomes a patchwork of disconnected islands. Another major threat comes from pesticides. Modern agriculture relies heavily on chemicals designed to kill insects that damage crops. But these chemicals do not distinguish between harmful pests and beneficial pollinators. Some pesticides affect bees' nervous systems, impairing their ability to navigate. A forager exposed to these chemicals may leave the hive, find food successfully, and then lose the ability to remember how to return home. The bee dies alone, and the colony loses a worker. Multiply this by thousands, and the hive begins to collapse. One class of pesticides, known as neonicotinoids, has drawn particular concern from scientists. These chemicals spread through the entire plant, including its nectar and pollen. Bees unknowingly consume small doses every time they feed. Even when the dose is not immediately lethal, long-term exposure weakens immune systems and reduces reproduction. It is not a sudden poison, but a slow erosion of resilience. Parasites and diseases have added yet another layer of pressure. The most notorious is the Varroa mite, a tiny parasite that attaches to bees and feeds on their bodily fluids. Imagine a tick the size of a dinner plate attached to a human. The mite weakens bees directly and spreads deadly viruses between them. Colonies already stressed by habitat loss and pesticides struggle to fight these infections. A healthy hive can survive many challenges, but multiple threats at once push it beyond its limits. Climate change introduces additional complications. Flowering seasons are shifting as temperatures rise. Some plants bloom earlier in spring, before bees are active. Others bloom later, after peak foraging periods. This mismatch disrupts the timing of the ancient partnership between bees and flowers. Droughts reduce the number of blossoms. Extreme weather destroys colonies or limits foraging time. The environmental stability bees relied on for millions of years is becoming less predictable. Each of these threats alone would be challenging. Together, they create a cascading effect. A colony weakened by poor nutrition becomes more vulnerable to disease. Bees exposed to pesticides become less effective foragers, reducing food supplies. Parasites spread more easily in stress colonies. Over time, the hive reaches a tipping point. The consequences extend far beyond honey production. Global agriculture relies heavily on pollinators. It is estimated that roughly 1/3 of the world's crop production depends on pollination by insects, especially bees. Without them, yields of many fruits, vegetables, nuts, and seeds would decline dramatically. Staple crops like wheat, rice, and corn rely less on pollinators, but they do not provide the full spectrum of nutrients humans need. Many of the most nutritious foods, rich in vitamins, minerals, and antioxidants, depend on bee pollination. Imagine grocery stores with fewer colors, fewer fruits, fewer vegetables, higher prices, reduced variety, diets becoming more limited and less nutritious. The disappearance of bees would not cause immediate famine in most countries, but it would reshape global food systems in profound ways. Prices would rise. Access to healthy food would become more unequal. Agriculture would need to rely on expensive and inefficient alternatives, such as hand pollination. In some regions of the world, farmers already perform pollination by hand using brushes and cotton swabs. The process is slow, labor-intensive, and costly. A single beekeeper can manage millions of pollination events in a season. Replacing that workforce with humans would be almost impossible on a global scale. Yet despite these alarming trends, the story is not entirely bleak. Awareness of pollinator decline has grown significantly in recent years. Scientists, farmers, governments, and ordinary citizens have begun searching for solutions. Wildflower corridors are being planted along roads and in cities. Some countries have restricted the use of certain pesticides. Beekeepers are developing strategies to manage parasites more effectively. Researchers are studying bee health, behavior, and genetics to better understand how to support their survival. The fate of bees is no longer an invisible issue hidden in fields and forests. It has become a global concern. And perhaps for the first time in history, humans are beginning to realize how deeply our own survival is connected to the survival of a small insect. Because when bees struggle, the systems that support life on land begin to tremble. And yet, even with all these threats, bees have not disappeared. Not even close. In fact, in many places their story is becoming one of resilience and adaptation. To understand why, we have to shift our perspective. For most of this story, bees have seemed fragile, overwhelmed by modern pressures. But evolution has spent over 100 million years shaping them into survivors. Their greatest strength has always been adaptability, and now that strength is being tested in real time. One of the most surprising discoveries scientists have made in recent years is how quickly bee populations can recover when conditions improve. When pesticide use is reduced, when wildflower habitats are restored, and when parasites are managed effectively, colonies often rebound far faster than expected. This is because bees reproduce quickly, and a healthy queen can generate tens of thousands of workers within a single season. The system that once evolved to survive harsh winters and unpredictable environments still holds tremendous power. Urban environments, once considered hostile to pollinators, are now revealing an unexpected secret. Cities can actually become safe havens for bees. While cities lack large natural ecosystems, they often contain a surprising diversity of flowering plants and parks, gardens, balconies, and roadside plantings. Unlike agricultural land, urban spaces rarely use large-scale pesticides. As a result, some cities now host thriving bee populations, sometimes even healthier than those in rural farmland. Rooftop beekeeping has appeared in places where few people would expect it, turning concrete skylines into pollinator habitats. This discovery has reshaped how scientists think about conservation. Saving bees is no longer seen as a task limited to remote wilderness or large farms. It can happen in backyards, schoolyards, and city streets. A single patch of flowers can become a refueling station for dozens of pollinators. A balcony garden can support an entire microecosystem. Small actions, multiplied across millions of people, begin to create corridors of survival. But bees are not only ecological heroes. They are also cultural companions of humanity. For thousands of years, humans have admired, studied, and depended on them. Ancient cave paintings depict honey gathering. Early civilizations kept bees in clay hives. Honey was one of the first sweeteners humans ever used, long before refined sugar existed. In many cultures, honey symbolized wealth, health, and even immortality. Beeswax illuminated homes as candles. Propolis, a resin collected by bees, was used in traditional medicine. Long before modern science understood pollination, humans recognized that bees were valuable. Today, that ancient relationship is evolving into something new. Technology is beginning to assist bees in ways that would have seemed impossible just decades ago. Researchers are developing tiny sensors that can monitor hive temperature, humidity, and activity levels. These smart hives allow beekeepers to detect problems early and respond quickly. Artificial intelligence is being used to analyze bee behavior and predict colony health. Scientists are even exploring robotic pollinators, not as replacements for bees, but as emergency support in areas where pollinator populations are under severe pressure. At the same time, agriculture is slowly changing. Farmers are increasingly planting wildflower strips between crops to provide year-round food for pollinators. Crop rotation and diversified farming practices are helping restore ecological balance. Some vineyards and orchards now manage land specifically to support pollinators, recognizing that healthy ecosystems improve crop yields and stability over time. The realization is spreading. Protecting bees is not an environmental luxury. It is an agricultural necessity. There's also a growing movement to protect wild bee species. While honeybees receive most public attention, they're only one species among more than 20,000 types of bees worldwide. Bumblebees, mason bees, leafcutter bees, and many others play essential roles in pollination. Some are even more efficient pollinators than honeybees for certain crops. Protecting pollinators means protecting this entire diverse community, each species contributing its own unique skills to the global ecosystem. Perhaps the most hopeful aspect of this story is how accessible the solutions can be. Unlike many global environmental challenges that require massive infrastructure or technological breakthroughs, helping bees often begins with simple changes. Planting native flowers, reducing pesticide use, supporting local beekeepers, creating spaces where wild plants can grow. These actions may seem small individually, but collectively they create a network of habitats stretching across landscapes. The relationship between humans and bees is entering a new chapter. For millions of years, bees shaped the world quietly, without human awareness. Now humans are beginning to understand the depth of that relationship and the responsibility that comes with it. The future of bees is not solely in the hands of scientists or governments. It rests in the choices made by communities, farmers, gardeners, and individuals across the planet. Bees once transformed the earth by forming a partnership with flowers. Today, a new partnership is forming between bees and humans. And this partnership may determine the future of both. If you step back and look at the full story, the question we started with begins to transform. Why do bees exist? At first, the answer seemed simple: pollination, food, agriculture, survival. But now the picture is much larger than that. Bees exist because life on Earth is built on relationships, and they are one of the most powerful connectors in the entire web of life. To understand this, imagine the planet not as a collection of separate species, but as a vast network of exchanges. Energy flows from the sun to plants. Plants convert that energy into sugars. Animals eat plants. Predators eat animals. Decomposers recycle everything back into the soil. Every organism is part of a chain. Every chain is part of a system. And within that system, bees are among the most important bridges ever evolved. When a bee moves from flower to flower, it is not simply collecting nectar. It is connecting genes across landscapes. Each grain of pollen is a microscopic packet of genetic information. When bees transport pollen, they allow plants to reproduce, mix genetic material, and create new generations. This process strengthens plant populations, making them more resilient to disease, climate shifts, and environmental change. Without pollination, plant reproduction would slow dramatically. Diversity would shrink. Ecosystems would become fragile and simplified. Biodiversity is not just about having many species. It is about stability. In diverse ecosystems, if one species struggles, others can compensate. This resilience protects forests, grasslands, wetlands, and agricultural systems alike. Bees help maintain that diversity. They act as silent gardeners of the planet, enabling flowering plants to flourish across continents and climates. This influence extends far beyond farms and orchards. While plants depend on pollinators just as much as crops do, these plants form the foundation of natural habitats, providing food and shelter for birds, mammals, insects, and countless other organisms. Remove pollinators, and the ripple effects move through entire food webs. Herbivores lose food sources. Predators lose prey. Landscapes begin to change in subtle but profound ways. It is easy to think of bees as small and fragile, but their collective impact operates on a planetary scale. Entire forests depend on pollinated plants for regeneration. Grasslands rely on flowering species that support grazing animals. Even rivers and waterways are affected because plant roots stabilize soil and prevent erosion. Bees help maintain the vegetation that holds ecosystems together. There is also a deeper lesson hidden within their story. Bees demonstrate how cooperation can outperform competition. A single bee is vulnerable and short-lived. A colony, however, becomes something greater than the sum of its parts. Through collaboration, communication, and shared purpose, thousands of individuals create a system capable of surviving seasons, disasters, and environmental change. This idea resonates beyond biology. The hive becomes a mirror of larger systems, societies, economies, even civilizations. Complex systems thrive when individuals contribute to shared stability. The success of the colony depends on the success of the group. In this way, bees offer not just ecological value, but philosophical insight into how interconnected systems endure. Their story also challenges how humans measure importance. In daily life, bees are easy to overlook. They're small, quiet, often unnoticed. Yet their influence touches nearly every meal, every landscape, and every ecosystem. Their existence reminds us that the most essential forces in the world are often the least visible. And perhaps that is the most powerful answer to the question. Bees exist because life requires connection. They exist because flowering plants evolved to partner with pollinators. They exist because ecosystems need bridges that link species together. They exist because cooperation can shape entire planets. In a world increasingly shaped by human activity, the fate of bees and the fate of humanity are becoming more closely linked. Protecting pollinators means protecting food systems, biodiversity, and ecological stability. It means safeguarding the quiet processes that make life possible. The next time a bee lands on a flower, the moment may seem ordinary. A tiny insect gathering nectar. A simple act repeated millions of times each day. But within that moment lies a process that has been unfolding for over 100 million years. A partnership that helped shape the modern world. Bees exist because the earth needed pollinators. Because flowers needed partners. Because ecosystems needed connectors. And now, more than ever, the future may depend on ensuring that this ancient relationship continues. The question is no longer just why bees exist. The question is whether we will protect the delicate system that depends on them. And yet, even after everything you've just imagined, the most unsettling part is this. The story does not have to end this way. The disappearance you've been picturing is not a certainty written into the future. It is a trajectory, a direction, a slow-motion chain reaction that can still bend. Because the same fragile web that can unravel also has the ability to mend if the hands pulling the threads choose to stop. Right now, in quiet corners of the world, the opposite of collapse is already happening. In cities where rooftops were once bare concrete, small gardens have begun to bloom. Balconies that once held nothing but metal railings now carry pots of lavender, basil, and marigolds. These are small acts, almost invisible from a distance, but to a bee flying across a gray skyline, they are islands of survival. A single balcony can feed hundreds of pollinators in a season. A city block filled with them becomes a corridor of life. Farmers in different countries are starting to leave strips of wildflowers between their crops. At first glance, it looks inefficient, land not used for production. But something surprising happens. The bees return. Yields stabilize. Crops become more resilient. The land begins to breathe again. What once seemed like wasted space becomes a lifeline that quietly pays for itself. Scientists are learning how deeply connected these insects are to the rhythm of the planet. They are tracking migration patterns, studying the chemistry of pesticides, mapping the invisible highways pollinators use to move across continents. Every year, the picture becomes clearer. When pollinators thrive, ecosystems stabilize. When ecosystems stabilize, food systems follow. And when food systems stabilize, human societies gain something priceless: time. Time to adapt. Time to innovate. Time to choose differently. Because this story was never only about bees. It was about the illusion that nature is separate from us. For centuries, it felt as though food came from supermarkets, not from fields. That abundance was permanent. That technology could always replace what disappeared. But pollinators expose a truth we cannot engineer our way around. Life depends on relationships. Tiny wings brushing against petals. Invisible exchanges of pollen. Millions of small interactions repeating every day without applause or recognition. The disappearance of pollinators would not feel like a single catastrophic moment. It would feel like silence spreading. Fewer colors in markets. Higher prices on shelves. Longer supply chains. More substitutes, more artificial flavors. More words like synthetic and replacement. And eventually, a quiet question appearing in the background of daily life. How much of the world we knew has slipped away without us noticing? But the reverse is also true. Recovery would not arrive with a dramatic announcement. It would appear gradually, almost shyly. More butterflies in the summer air. More fruit on backyard trees. Fields humming again with the sound most people stopped hearing long ago. The future of pollinators will not be decided by a single invention or a single law. It will be shaped by millions of small choices repeating every day. What gets planted? What gets sprayed? What gets protected? What gets ignored? And this is the part of the story where the scale shifts from global to personal. Because the fate of pollinators is not locked inside laboratories or government offices. It exists in gardens, parks, farms, schoolyards, roadside verges, and empty lots. It exists in the spaces people rarely think about. The margins, the edges, the overlooked places where wildflowers can grow if they're simply allowed to exist. If the world lost 30% of its food overnight, the shock would be immediate. But saving pollinators is not about dramatic emergencies. It is about preventing a slow one. It is about noticing the quiet work happening around us every day and choosing to protect it before its absence becomes impossible to ignore. Imagine walking through a market decades from now. The tables are crowded with fruit of every color. The smell of coffee fills the air. Chocolate bars sit beside baskets of almonds. Someone picks up a peach and presses gently to see if it's ripe. Children argue over which berries taste sweeter. And none of them are thinking about bees. None of them are thinking about pollination. Because the system is still working. The invisible machinery of life is still turning quietly in the background. That ordinary moment, simple, unremarkable, easy to take for granted, is the real victory. Not headlines, not breakthroughs, just continuity, the preservation of normal life. The story began with disappearance, with shelves growing emptier and flavors fading from the world. But it ends with a reminder that the future is not something that happens to us. It is something that unfolds from the accumulation of choices made long before the consequences appear. The smallest workers on Earth carry one of the largest responsibilities, and they have been doing it for millions of years without asking for anything in return. No recognition, no gratitud, only the quiet continuation of the relationship that allows life to keep moving forward. The question is no longer what happens if pollinators disappear. We already know the answer. The real question is whether we decide that their quiet work is worth protecting while there is still time to do so. Because tomorrow morning, coffee can still exist. Apples can still grow. Chocolate can still melt in the warmth of human hands. Not because the world is guaranteed to stay this way, but because it is still possible to keep it that way. And sometimes, the most powerful ending is simply the one where the silence never arrives.